We'll first recap what we did with respect to module 4 last time. Expecting again that you people solve the questions of those 3 problems. And then we cover the remaining portion of module 4, and then we solve the MCQ on module 4, as well as those who have missed module 3 ka MCQ, they'll be attempting that as well. Then you are expected to complete the questions of module 3 and 4 and upload on GCR within the deadline. Okay. Yes, Siddesh. So how did we begin with module 4 was, we tried to understand what is dynamic programming. Greedy was also targeting optimization problems. Dynamic programming is also targeting optimization problems. Then over here again, the problems are divided into sub-problems, but the sub-problems are overlapping or dependent. So what we do is we solve one problem once and store the result in a tabular manner, so that I can reuse that later. Then we had compared divide and conquer with dynamic programming, greedy with dynamic programming. The same were discussed in lab as well. Then we saw what is principle of optimality, because that is the important thing in dynamic programming that guarantees you optimum solution, stating that in a sequence of decisions, each subsequence needs to be optimal to guarantee the total sequence as optimal. Then in the syllabus, we have these 6 problems, of which 3 we have done, that is multi-stage graph, single source shortest path, and all pair shortest path. We will be today covering 0-1 knapsack, traveling salesman problem, and longest common subsequence. So multi-stage graph was, there are multiple stages, there might be multiple nodes at these stages, and we need to find a path from source to destination. So as we saw in this example, greedy was applied. And then for this particular example, when we tried to apply greedy, this failed, and that is why we chose some other method to find the shortest path. That was a brute force and manual method. But to achieve this first, we used dynamic programming, and we saw dynamic programming applied करने के बाद यही cost आएगी. So what was dynamic programming for multi-stage graph? Either we are moving in a forward manner and reasoning it backwards, or the other method was we are moving in a backward manner and reasoning it forward. In this case, what was happening was, मुझे source से target की distance find करनी है, तो from the source I currently know what is the direct cost, and then remaining I do not know. The remaining which I do not know, so connecting vertices से again I form the same formula that उन connecting vertices से distance we know, and the remaining I do not know. So likewise, I keep writing these equations, and because here we had only 3 stages, so that is why over here dt ki direct cost I am able to compute from here. So this is for node A. Likewise, we did for node B and for node C in the next slide. And then finally, in S to T equation, we put in these values of AB, AT, BT, and CT. That is the minimum cost. And finally, we get the minimum cost. And through backward reasoning, we are able to find the minimum cost path as well. Okay. Similar technique we use for backward approach, जहाँ पर मुझे source to target ही find करना है, but target से distance direct पता है to D to E and to T, sorry, to D to E and to F, and then I do not know S to D, S to E, and S to F, and slowly I try to find these distances, and that is why I move backward, framing the equations, and then try to fill them in a forward manner to reason the minimum cost from source to target. Any one of you online and offline solve this? The attendance is very less. Please put on your group for students to join, because the topics 2 out of 3 are tough for you to understand for the day. ये try किया किसी ने? And I hope you must all have read the notice. Your second ISA is offline or online? But the kind of response I do not think all of you are aware, because you are still not participating in the class. So again, similar approach, please try to practice for these two questions. For both forward and backward, you never know what is asked. Then we have moved to shortest path problems, जिसमें कि shortest path problems were introduced to us in greedy module. There we had seen single source shortest path. यहाँ पर same problem को हम solve करेंगे using another method, that is Bellman-Ford. The difference between Bellman-Ford is able to operate upon negative weight edges and is able to identify if a negative weight cycle is there, which Dijkstra was not able to. And we also saw all-pair shortest path algorithm, that is Floyd-Warshall. So again, in Bellman-Ford, the algorithm, the complexity, and given a graph, you need to find the single source shortest path from the given source. And as we had seen earlier, relaxation of edges. So again, that step is over here as well. Then we had seen this example wherein initially all these costs are infinity. I keep updating the cost as we iterate over the weighted graph, the weighted and directed graph. So after this, from T, the connecting vertices need to be updated with the cost, with the minimum cost. Similarly, though we have iterated over all the vertices, but these costs keep on reducing because there are negative weight edges. And we go on doing this till further there is no reduction in cost at these nodes. So this is how we are finding from source S to every other vertex across single source shortest path. So again, this question was given to you people to practice. Again, a question to you: has any one of you tried this? So there is only one person who had tried the first one, the second one. You people can see where you stand. Then we had moved to all-pair shortest path. So there is a concept as single source shortest path को ही अगर हम n times run करते for each and every vertex, then also we can find all-pair shortest path. But the time taken will be like Dijkstra's algorithm normally takes n square time if there is a adjacency matrix. If I iterate over n vertices, it will become n cube. अगर हमने adjacency list use किया है या priority queue use किया है या heap use किया है data structure, then the complexity becomes v log v plus e. N times of this because we are iterating over n vertices. Similarly, Bellman-Ford for time taken is nm for single source shortest path because there are two loops iterating over the number of vertices of edges. If I iterate this again for n vertices for all-pair shortest path, the time taken becomes n square. Similarly, in Floyd-Warshall algorithm, let us move to the algorithm directly, wherein we have those three loops. So because of these three loops, the complexity directly becomes cubic. Then this is a recurrence relation for Floyd-Warshall, wherein the cost of from vertex I to vertex j, we are trying to find the cost with every other intermediate vertex as the intermediate one. So that will remain the same, or that might be a lesser cost via that vertex. So if it is lesser, I'll update the cost. So this is another example that I have added into the slide for your reference, because otherwise you people will say that the content shared was having direct solution. So direct solution is not allowed in the exams. So it is better for you to show कि सबसे पहले A1 find करने की, A0 is your cost matrix, the connections in the graph. A1 becomes when a first column and first row are being considered. Similarly, A2 becomes when these and these are being considered. A3, third row and third column and third row, and A4 is fourth column and fourth row. So this is your final matrix, and these are to be designated as A superscript 0 to A superscript. So this example we had seen last time. This one you people can practice, and there was one more given to you for practice. So this was all that we did last time. Now let us begin with the portion that we have to cover today. Anyone, any idea of what is knapsack problem? Which variant we have done in greedy and what is this variant?
हम फ्रैक्शनल किया था ग्रेडी में.
ग्रेडी में फ्रैक्शनल किया था. ओके शिव. कैसे बोला? उसके बाद प्रिंट की बात नहीं हो रही है. We are talking about knapsack. How the knapsack in greedy was different and how the knapsack in dynamic is different. डायनेमिक का knapsack अभी पढ़ा नहीं है लेकिन स्लाइड पे नाम दिख रहा है. So in greedy we had solved fractional knapsack problem wherein your xi values could be a fraction between 0 to 1. यहाँ पर because the problem is 0 1 knapsack, so either we are picking the item or we are not picking the item. जो भी solid items हुए, definitely I cannot take a fraction of those. वहाँ पर loose items were also allowed. So because we are either picking the item or not picking the item, that is why x का term नहीं आएगा यहाँ पर. Even if you include x term, the value can be either 0 or 1 or binary value. So our objective again is to maximize the benefit of the profit over all the items in the set, and the sum of the weights of the chosen items must be less than equal to the maximum capacity. So exceed नहीं कर सकते definitely. So the concept is exactly the same. Only thing is we are not allowed to take fractional items. So let us see this example and you are asked to solve this. There is a box of width 9 inch. ये books हैं जिनका weight है, weight or the height we can call that as, weight कहना सही नहीं रहेगा, or width we can call that as. And the benefit earned of putting this book into the knapsack or into the box is given. So which book we should pick first? 2 inch जिसका weight है और $80 profit है because the maximum profit per unit weight is this. Next, because again the maximum profit per unit weight is out of the first item. Next, and we have to keep track of that we are not exceeding the width of the box. अभी 6 inch हो गई, 3 inches still left. I cannot
2 inch 2.
I cannot pick the fourth item because though it is giving me more profit, but it is exceeding the width, right? So I am picking. Who answered over here?
Third item.
Members.
Some Beneath your answer. कौन सा item pick करेंगे?
Third.
So all of you agree that we are picking the next item as 3. So my knapsack total width now is 8 and total profit earned is 106.
106.
Another example. So in this example, again, this is a pair of profit and weight. So first items are all profits and the second are all weight, and total capacity knapsack is 20. So I'm picking, let us say one by one, I'm selecting the items as we do in dynamic programming. अभी पिछला example कैसे किया था? Greedy methods use किया था that I have a greed of maximizing profit per unit weight. Now in dynamic, because we are moving bottom up approach, so we are picking items one after the other. So यहाँ पर 3,2 code we can use. Still the capacity left is 18. 5,4 the capacity left is 16. Then 8,5 the capacity left is 9. 4,3 the capacity left is 6. And then last item we cannot put, otherwise the capacity will be exceeded, right? So हम क्या करेंगे इसमें? We have to either take the item or not take the item. So we are not picking the fourth item and picking the last one, so that the knapsack is full as well as my profit is maximized. क्योंकि इस item को pick करने का profit सिर्फ 4 था, whereas if I do not select this and select this, the profit is more. So how am I able to do this? Because we are storing each and every value that we'll see in the approach. So actually what we are doing here is, I'll try to explain 0-1 knapsack using this video link.
Zero one knapsack problem.
I was able to understand with this speed. If you're not able to understand, I'll reduce down the speed.
In this video, I will explain what is zero one knapsack problem and how it can be solved using dynamic programming. We will understand its approach. Next, I will show you a tabular method for solving this one. Then also I will
हाँ? अच्छा तुम लोग को आवाज कैसे आएगी? फोन पे ज्वाइन करो. Just a second, let those students join on phone. लिंक शेयर करो. ऊपर सेम पेज पे रखो और कीप इट 1.75 का स्पीड. हो गया स्टार्ट दोनों का.
show you a sets method for solving this one. So there are two methods. We will see both the methods. First of all, let us understand what the problem is. Here I have some 4 objects. For each object, there is some profit and there is some weight. And there is a bag of capacity M, that is 8 is given. The objective is to fill this bag with these objects. So can we put them all? See, the capacity 8 is 8, but the total weights of all these objects is 14. So all objects cannot be filled in the bag. So I have to carry few of those, some of those objects, there is a subset of those objects, and I have to carry them and sell them at other place. So once I sell, I get
इसका नाम बताओ. नहीं बंदे का नाम बताओ.
हम अब्दुल बारी.
Abdul sir.
अब्दुल बारी. तुम लोग तो कुछ बोलो नहीं. तुम लोग फिजिकल क्लास में क्यों नहीं हो? एंड इन द मॉर्निंग दोस 15 और 10-15 जितने थे वो कहाँ गए? मैं लिडिया मैम से नाम लेके एंड देन आई विल गेट बैक टू यू. राइट? हो गया तुम दोनों का?
this profit. So I have to fill the object such that the total profit is maximized. And I have to give the solution in the form of a set for each object. Like for example, this is included and this is not included or not included. Like this, I have to write down which one is included and not included. So it means I can write down each xi either 0 or 1. It means the values can be 0 or 1, but not fraction. So it means that the object that I am going to carry are not divisible, breakable. So I cannot take the fraction of that object. So this means these are some solid objects. Maybe a mixer or microwave oven or a router. It can be something like this. So which I cannot take a half of a mixer in the bag. So these are indivisible objects. So either I should carry the whole object or don't carry it at all. So I have to carry the object such that the sum of their profits should be maximized and sum of their weights should be less than or equal to the capacity of the bag. Now let's know the approach of dynamic programming for solving this one. Now, few important things about dynamic programming. Dynamic programming is useful for solving optimization problem. Yes, this demands maximum results, so it's optimization problem. Second thing, dynamic programming says that a problem should be solved in sequence of decisions. So yes, we can take the sequence of decisions for every object. We can take, shall I include or not, include or not, include or not. So I can take decisions. I can even start taking the decision of the last object also, include or not, include or not. So usually in this one, we take the decision from last object towards first object. So we can take sequence of decision. Next thing, one more point that dynamic programming says that you should try all possible solutions and pick up the best one. Now, how many possible solutions are there? See, when I'm writing the solution in the form of zeros and ones, then it can be 0, 0, 0 means no object is included.
Yes, how many possible solutions will be there of online people? तुम्हारा तो आगे बढ़ गया होगा, सुन लिया होगा. Yes, any one of you? If we are doing it through brute force method, then total number of possible solutions for picking the subset from the set will be yes 4 होगा.
हम 4 होगा ना?
4 होगा. Number of possible combinations of picking these items. I can pick first, second, third, fourth. I can pick 1, 2, 2, 3, 3, 4, 4, 1. I can pick 3, 3 का combination. I can pick all 4. So how many such combinations? तुमने भी सुन लिया होगा आगे. So the combinations are exponential. That is 2 to the power 4. Okay. So now we'll see how dynamic programming reduces this count.
Included, or 1 1 1 1 means all objects are included, or 0 0 0 1 means only first object is included, or first object is included, or first two objects are included. Like this, there are many possible solutions, and some of them may be feasible, some may not be feasible. Like
So we can understand this is 4 bits का binary digit है, so 16 rows बन जाती है उसकी, right? Those are all the possible combinations of whether to pick or not to pick that item.
all objects I cannot include. So anyway, I should try all of them and pick up the best one. So total, how many solutions will be there? So like 4 zeros and 1s form. If I continue, so I'll be getting 2 power 4 solutions. So I should try 2 power 4 solution. For n objects, it will be 2 power n solutions. So if I try out all, then the time complexity will be 2 power n. This is too much time consuming. So dynamic programming shows an easy method for doing the same thing. We will be indirectly trying all 2 power n, right? But not directly. So we'll not spend that much time. Let us solve this problem using tabulation method. Tabulation method, let us see how to fill these values and how to get the solution for this problem. So for solving, as the capacity of the bag is 8, so I have taken the columns starting from 0 to 8. So this means that though the capacity is 8, but we'll not consider that 8 at once. So we'll add weight 1 by 1. So starting from 0, then let us assume weight is 1, weight is 2, and so on. Then rows, 4 objects, so I have taken 5, 0, 1, 2, 3, 4. So starting from 0. So it means 1 by 1 we will consider the object. So initially we will not consider any object, means we will not include any object in the bag. So for filling this, we have a formula. So I'll show you formula after some time, after filling some values. So let us see. First row, as a 0 object, no object is included, then what will be the profit? So in these boxes, I'll be writing the profit. So there is no profit gained when no object is included. And even when the capacity of the bag is 0, this is the capacity, these are the weights, right? And these are weights and the profits of the objects. So these are the weights, and there is when 0 weight is there, then all these are 0, 0, 0. Next. Now we'll start filling. So for that, I'll consider first object. When I consider first object, I'll take this row and I will ignore all other objects.
So is this much understood? That is the initialization step in the algorithm. The first row and the first column are being initialized as 0.
And similarly, when I go to second row, I'll ignore the remaining and I will take the second object as well as the first object. I'll consider the first object also. So it means whenever I am in ith row, I will consider all the objects in the previous rows also. So for the first row, directly I can fill it. Let us see. First row, what is the weight of the first object? 2. So it can be filled only when the bag capacity is 2. So here, so what will be the profit? 1. So fill 1 here. Then this means this is same value, previous value. Usually we write previous value only if required. Then rest of the cells, the capacity of the bag is increasing, but how many objects I am considering? Only 1. So I don't have anything more to fill in the bag. So only that object I can fill and will be getting profit as 1, 1, 1 only. I'll fill the second row also, right? Third row also in the same way. Then I will write on the formula. Let us go to second row. I'm going to consider second object. So as I said, when I consider second object, I should also include the first object. So first let us look at the second object. See, the weight of the second object is 3. It can be filled.
So anyone, any idea? अभी कौन से cell में और कौन सी value लिखेंगे in the third row? If you have understood the second row, fill. Third row में? Third column में 2 values. Anyone online?
मिस थर्ड रो में सेकंड थर्ड कॉलम में 2 लिखेंगे और फिर पूरे
Okay. What is happening here is this is iteratively we are trying to increase the capacity of the knapsack. So iteratively जब increase करें, so in that case I cannot put in an item of weight 3 when the capacity is 0, 1 or 2. जब तक capacity iteratively increase होकर 3 नहीं हो जाती, I cannot put. And when I am putting how much profit I am earning is that is put in this matrix, that is the V matrix.
Fill in the bag only if the capacity is a 3. So in this cell only it can be filled. So what is the profit that I'll get? 2. So put 2 here. What about this side? It will be same value as the previous row. Then beyond this, what should come here? So as I said that when you are taking second object, you should also consider first object. So if I fill the second object also in the bag, total weight required is how much? 5. So this is 5 and total profit will be 3. So both the objects can be filled when the capacity is 5 and the total profit will be 3. So here both of them can be filled. Right? Both of them. I'm considering both of them. So now I have only 2 objects and this is giving for both the objects are filled. So rest of the values will be 3, 3, 3. Then what will be the value here? So as this is 2, so this will also be 2. So I can take the previous value or this value, whichever is maximum, I can take the same thing. Now I will fill the third object also. Then for the fourth object, I will show you the formula. Third object. When I consider third object, if you look at these, the maximum weight is this one, and as they are arranged in the increasing order of the weight, so this is weight is 4. So this object can be filled in the bag only if the capacity of the bag is 4. So this will be included in the bag when the capacity is 4. So the total profit that we'll be getting is 5. So this is 5. Then before that, whatever the previous row values are. So 2, 1, and 0. Now beyond this, let us see. See, when I am on the third object, I should also consider first and the second object also. So if I just check them, this is 4. And if I take these two objects, it will be total 6 weight. Weight is 6.
अभी कोई बताएगा in which cell what value will come in the row that we are filling कर
6th में 6 आएगा.
6th में 6 आएगा. Why?
नहीं नहीं, वो वहाँ पे हाथ पे जो भी उधर है
one value.
वही.
So 6th में because weight 2 plus 4 we are considering, so the profit will be 1 plus 5, so 6 will come here. Or anything else? 6 में 6 आएगा. और
7 में 7 आएगा.
7 में 7 आएगा. And can we add all the 3 items together?
No.
Because the weight will exceed, and that is why उतना ज़्यादा profit हम 8 profit नहीं ले सकते. Fine.
So these two objects I can fill if the weight is 6, right? So if I want to fill these two, then these two I can fill when the weight is 7. This two I can fill if the weight is 5. And what will be the profit? 3. This object itself is 5, right? Now I will consider these two 6, and the total weight will be 6. So at 6 it will be 6 only, right? And when I consider these two, so total is 7, and the profit is also 7. So at 7 the profit is 7. Can I include all 3? It will be 10, but the capacity of the bag is only 8, so I cannot include all 3. Then beyond this the value will be 7 only, and before this one the value will be same as this 5. Alright, now I will show you the formula, and I will fill 4th row with that formula. The formula is like this. If I call this table as V, then V of I, W, I is the row number, W is the column number, is maximum of V of I minus 1, that is from the previous row I should take, same value, means previous row value I should take, this is the meaning, or maximum of this one, or what, V of I minus 1, comma, weight minus weight of an object, Wi, plus profit of an object that you are considering. Now let us follow the formula and fill all these. First one, 4.
So why are we doing this here is because I can add WIF item only when the remaining capacity is W minus W1. Right? I repeat, I can add this WIF item जिसका profit PI है only when the remaining capacity in the knapsack is W minus W1. तो इसके लिए हम W minus WI वाले कॉलम में देख रहे हैं the previous item की profit value. And we are adding the profit of this ith item that I can include. Why can I include? Because remaining capacity अभी भी W minus WI है जो इस WI को include कर सकते हैं.
1. I will fill 4, 1. So V of 4, 1 is maximum of V of 3, 1. Like this is 4, so this will be 3, comma V of 3, weight is how much? 1 minus weight of an object. Weight of an object is 5. 1 minus 5 plus profit of that object is 6. Now this becomes 3, minus 4. There is no such location, so that value becomes undefined. So only this value will be defined. V of 3, 1 will be defined. So V of 3, 1 is what? 0. So I should take 0 only. There will not be any such index V of 3, minus 4. Yes, for that I have to take 0 only. So it means up to what I will be getting negative numbers? Up to 5th weight. So till here I should fill these values as it is only. So that's what I was saying, that this can be considered, or this can be considered in 4th. So write down its value and all previous values as it is. So the same thing here, because they will be getting negative. So till 5th weight, before that I have filled as it is. Now this 5th weight, how to fill, I will show you. For this value, 4, 5, V of 4, 5 is maximum of V of 3, 5, V of 3, weight is how much? 5, minus weight of this object is how much? 5, plus profit of this object is how much? 6. Let us see. V of 3, 5. 3, 5 is how much? 5. Comma. V of 3, 5 minus 1, 5 minus 5, 0. V of 3, 0. 3, 0 is 0. Plus 6. So which is greater? 6 is greater. So fill this value with 6. So that means this object is included here. Now 4, 6 I will find out. V of 4, 6 is maximum of V of 3, 6, V of 3, weight is 6, right? And the weight of the object is 5 plus profit of the object is 6. So how much this is? V of 3, 6 is how much? 3, 6 is 6. V of 3, 6 minus 1, 6 minus 5, that is 1. 3, 1. 3, 1 is how much? 0. 0 plus 6. So the answer is both are same only. So take 6 only. Next one, 4, 7. V of 4, 7. Maximum of V of 3, 7, V of 3, weight is how much? 7. So weight of the object is 5. 7 minus 5 plus profit is 6. So this is 3, 7 is how much? 7, This is V of 3 comma 7 minus 5 is 2. 3 comma 2. So 3 comma 2 is how much? 1 plus 6. So this is 1 plus 6. So this is 7 only. Both I am getting 7 or 7. So they are same only. Take 7. V of 4 comma 8. 4 comma 8 is.
Any one of you, what will be the value in the last cell? Online or offline? Either using the formula or using manually how we were doing it.
8.
Okay. The
Maximum of V of 3 comma 8 comma V of 3 comma weight is 8 minus the weight of an object is 5 plus profit is 6. 3 comma 8 how much? 3 comma 8 is 7 comma V of 3 comma 8 minus 5 is 3. 3 comma 3 how much? 2. So this is 2 plus 6. So how much this is? This is 7 and this is 8. So answer is 8. So this is how the table is filled. So I have used the formula for few cells in the last row, and this can also be filled directly also without the formula. Now let me show you how to fill this last row directly. I am considering fourth object whose weight is 5 and the profit is 6. So in fifth column, just write 6, its profit. And what to write on the cells before that? Same value as the previous row. This is what you do first. Then, beyond this, now the weight is 5. Beyond this, the capacity of the bag is increasing. So I can include other objects also. So let us check other objects what I can include. In the sixth column, this object is definitely because its profit is maximum, right? 5 plus 2, 7. At 6, nothing will happen. So take 6 only. At 7, I can consider these two. So this is 6 plus 1, 7. Then at 8, when the bag capacity 8, which of the objects I can consider? 5 plus 3, 8. So 6 and 2, 8. So this is 8. So whichever objects that you can consider, you just add them. And in that capacity they are fitting in, you write on the max total profit. So this is a simple method for filling the cells. Instead of following this complex formula, you can follow that method. So I have shown you both solution. I have to write down x1, x2, x3, x4 values. Now for finding these answers, actually I'll be taking sequence of decision now. See, the decisions can be taken only if you have the data. Yes, we have kept the data ready. The formula was used for filling this data. Now I have to take the sequence of decision. So how to solve? So actually I have to know which object should be included and which should not be included in the bag. So let us come with the maximum profit, that is 8, the last cell. This 8 is generated only in fourth row, and in that previous row you don't find 8 anywhere. So it means we got this 8 because of including fourth object only. So include the fourth object. Right? Profit is 8. Fourth object is included because 8 is not in previous row. Now what is the profit of the fourth object? 8 minus profit is 6. So this is 2. Now remaining profit is 2. Now check whether 2 is there in the third row. Now I have to check for the third object. Fourth, then third, then second, and then 1. So third object, 2 is there? Yes. It's the same value 2 is there in the previous row also? Yes, it is there. So it means it is not because of third object. So don't include third object. Now let us consider second object. Is it 2 there here in the second row? Yes, 2 is there here. Is it there in the first row also? No. So it means this we got because of inclusion of the second object. So take this as 1. So now remaining is 2 minus 2. So 0. Now 0, was it there in the first object? So I have to consider the first object. Yes, 0 was there in the first object row. Was it there in the 0th also? Yes, it was there in the 0th also, this row also. So it means don't include the object. So this is the solution. So it means which objects are included in the bag? X2 and X4. 2 objects are included in the bag. So that is X2 is this one, X4 is this one. So total profit will be 8. So this is the maximum profit of 0 knapsack problem. Next I will solve it using sets.
So that was all what I had to share. Now let me move back to the slide. I hope majority of students must have understood. If you have not, then again you can refer and definitely you'll be able to understand. तो कर दो। मजा आ गया ना तुमको क्लास में YouTube सुनने को मिल गया तो आगे सुनते चले। ठीक है, so this is what he told. We in dynamic programming, that is why there was a need of filling that initial row as empty. Why? Because we for filling the next one we always require the previous one. The previous कुछ तो होना चाहिए starting point के लिए. So whenever in the algorithm also we are initializing, we initialize the initial row and the initial column as 0. तो जब भी जो आइटम कंसिडर कर रहे हैं उसकी कैपेसिटी एक्सीड होती है knapsack की remaining capacity से, we are filling it as the same. Otherwise what we are doing is we are filling it with the previous row, that is k minus 1, and which column? W minus wk column. Why? Because अगर capacity उतनी कम होगी then only I can include the wkth. So this is how, this is another example wherein the same steps are being shown. Arrows define कि कौन से particular cell में profit को add करके we are filling these. So again this you can practice. And again, we are looking at it in the same manner. Backtracking करके we are identifying which items are to be included. So 11 as it is not there in the previous cell, so this item is included. Then again we reduce its weight, we reduce its profit, weight, and then we check 5 minus होगा 5 है 5 है इसका, तो 6 पे आए, 6 ऑलरेडी है इसलिए इसको नहीं लिया। फिर अगेन इससे पहले 6 नहीं है तो 6 minus 4 होके 2 यहाँ पर आया, और because 2 is not there in the previous row, so again 2 minus 2 करके we are reaching. So that was all about 0-1 knapsack. Again, this example you can practice, that is on the slide, as well as these two examples. Now let us have a look at the algorithm. So initially in the knapsack, you need to initialize the 0th column and 0th row. ये for loop किसके लिए है? Column के लिए कि row के लिए? Row के लिए. So this is 0 0 0 1 0 2. So this is for the row. Column कहाँ पे initialize हो रहा है? So let us move further. What is happening here is these are my n items which are to be checked. That is your n rows, and these are your n columns, wherein I am incrementally increasing the value of W up to capital W, right? And what do we need to check is कि जो भी next item का weight we need to put in the knapsack, if it is less than the remaining capacity which we are incrementally increasing, then we are iteratively following the equation that was written in the previous slide. Same equation, b I minus 1 comma w, and उसका benefit add किसमें करना है? I minus 1 previous row and w minus wi column. And here only we are keeping a pointer so that we do not we can backtrack later that I am using this item. Why? Because the weight was lesser than the required weight. अगर नहीं था ऐसा, then I am keeping the profit as the same previous row, same cell, and I am not including this item. This entire thing gets computed and we are returning this n comma w size का B matrix. जो video में they have called it as V matrix. And this is the process that he had told. Initially my K value is capital W, मतलब पूरी की पूरी capacity, क्योंकि हमें backtrack करना है bottom to up. That is why the loop also has been taken reverse. If keep of I comma k is 1, so if I have selected this particular item, then I will reduce k value, that is remaining capacity, by that particular item, and we go on doing this till my knapsack value may not get reduced to 0. अगर fully knapsack fill हो रही है तो reduce हो जाएगी 0 तक, जैसा example में हो रहा था. But in some cases, as we had seen in one of the examples, wherein the value will not, the capacity will not be full. So why is the running time n into w here? So because this is a matrix which is to be filled, there are n rows and capital W columns. That is simple. So I hope people have understood 0-1 knapsack. So again, in the exam, you can do in any of the manners. If it is explicitly asked for you to apply the algorithm, then you have to show it using this particular step. What are the values being filled in the cells? जहाँ पर भी value change हो रही है, वहाँ पर you have to show. If it is not asked manually, you have to solve, and directly you can show that table, irrespective of how these values are coming. If you can show these arrows neatly, then it is acceptable, so that we directly get to know कि ये value कहाँ से modify. अगर यहाँ पर neatly नहीं आ पाएगा, then you have to write कि कहाँ पर changes हो रहे हैं. Right? Now let us move to the next topic. That is traveling salesman problem. Anyone, any idea what is TSP? I was very definite that people might be knowing. Traveling salesman problem क्या होती है? Online people. Okay. I'll explain the problem. As it is mentioned on the slide as well, we have a directed graph. We need to traverse and visit each and every vertex, starting from the originating city and reach back to the originating city, travel each vertex exactly once and find the minimum cost. So this is like something like a postman who has to visit a number of places, and he has to decide the redundancy now in visiting these places so that his time is saved, money is saved, and he needs to get back to the post office. He needs to deliver at different places exactly once. ऐसा नहीं है कि वहाँ की कुछ post दे दी और फिर दोबारा he has to visit, so that will be a costly thing. So again, this is an optimization problem, and we are considering optimization problems only in dynamic programming. So G is a directed graph. Again, we have vertices, we have edges. Edges are given along with their cost. A tour for the graph should be such that all vertices should be visited only once, terminating at source vertex with tour of minimum cost. That will be the sum of cost of edges of the tour. So again, we'll watch this video for this and then come back to the slide of the same person. लोग लगा लो फिर बता देना मुझे. मुझे तुम लोग का
Salesperson problem. In this video, I'll explain what does it mean by traveling salesperson problem. Then I'll show how this problem is solved using dynamic programming approach with the help of formula. Here a weighted directed graph is given, and this is the cost adjacency matrix for this one. There's an edge bidirectional edge shown here, so these are actually parallel edges, but instead of avoiding too many edges, a single edge with either direction is given here. So the cost of going from vertex 1 to 2 is 10, and 2 to 1 is 5. So the cost in either direction may not be same, the costs are different here, may be same, may not be same, so here they are different. Now the problem is, we have to select any one of the vertices as a starting vertex and find out a path such that it is going through all the vertices and returning back to the starting vertex. So it should form a cycle covering all vertices. Let us see how dynamic programming can be used for solving this problem. As you know, the dynamic programming says that try out all possible solution and pick up the best solution. Now trying out all possible solution may be a time consuming work, but it shows an easy method of doing it. So here trying out all possibilities is nothing but brute.
Okay, again a question. If I am trying out all the possible combinations or path find करना है, so what will be the time taken or the complexity or all possible combinations कितने हो जाएंगे? One से मुझे कहाँ पर जाना है? How many possibilities are there? 3. Then next तीनों में से कोई एक choose किया है, तो how many possibilities are there to move further?
2.
So likewise, what should be the time complexity if there are n vertices? N minus 1 factorial or n factorial, so that comes out as big O of n factorial. तो भी factorial complexity है and उसको हमें reduce down करना है, right? There we had exponential complexity and we were reducing down that. So these are basically all NP hard problems that we'll see in the last module, and we are trying to solve these using some better method.
Brute force approach. So let us see how this brute force approach is applied and how we can try all possibilities. I'll show you through all possibilities, then I'll show you how dynamic programming makes it easy. So first let us see. I will select the starting vertex as 1. If I select the starting vertex as 1, then I can go to vertex 2, or I can go to vertex 3, or I can go to vertex 4. So if I select 2, then other possible vertices are 3 and 4. If I select 3, the other remaining are 2 and 4. If 4, then other remaining are 2 and 3. Then after 3, the remaining vertex will be 4 only. Here the leftover vertex is 3, leftover vertex is 4, leftover vertex is 2, and that is 1, 4, 2 is already over, so 3 is remaining. This is 1, 4, 3 is already over, so 2 is remaining. See, these are the possible routes that a salesperson can take. He can start from 1, then he can go to 2. He can start from 1, then go to 2, then 3, then 4, or 1, then 4, then 4, then 2, then 4, then 3. 1, 3, 4, 2, like this. There are many possible routes. Then after that, he has to return back to starting vertex 1 only. See, after 4, he has to come back to 1, come back to 1, come back to 1, right? Now I should know the minimum cost route from starting vertex 1. If I select this one, then I have to know the cost of all these. So the problem becomes very big. Let us start solving it from bottom. If salesperson is on 4th vertex, then what is the cost? Where he has to go remaining? When he is on 4th vertex, then he has to return back to vertex 1. So vertex 1 cost is 8. This is 8. If he's on 3, what is the cost of returning back to vertex 1? 3 to 1 is 6. And this is 4. Again, it is 8. From 2 to 1 is how much? 5. this one. Then 3 is already 6 and 2 is 5. So I have written the cost here where he has to return back to the starting vertex 1. Then if I say that he is on vertex 3, then 12. 12 plus 8, this is 20. And he is on 4, he has to go on 3 and then return back to vertex 1. So 4 to 3, how much? So 4 to 3 is 9 plus 6. So this is 9 plus 6, this is 15. Now suppose he's on vertex 2, then where he has to go next? Vertex 4 and then return to the vertex 1. So 2 to 4, how much? 2 to 4 is 10. 10 plus 8. So this is 10 plus 8 is 18. He's on 4, he has to go to 2, then return back. So 4 to 2 is how much? 8. 8 plus 5. So this is 8 plus 5 is 13. He's on 2, he has to go on vertex 3 and return back to vertex 1. So 2 to 3, how much? 2 to 3 is 9. 9 plus 6. So this is 9 plus 6 is 15. Right? So he's on vertex 3, he has to return back to 2. So 3 to 2, how much? 3 to 2 is 13. 13 plus 5. So 13 plus 5 is 18. So I started from the bottom. See, I'm considering that he is on vertex 3 and remaining vertices are he has to go on 4 and then return back to 1. Now let us go one more level up here. Now where he is on vertex 2, vertex 2. Then what are the remaining vertices? 3 and 4. So either he can go to 3 then 4 or he can go to 4 then 3. I have to take minimum out of these two, minimum. So let us see, 2 to 3, how much? 2 to 3 is 9. So this is 9 plus, how much it is? 20. And 2 to 4, how much? 2 to 4 is 10 plus, how much this is? 15, which gives minimum result? 25. So this is 25. Now same way, 3 to 2, 13 plus 18. And this is 3 to 4 is 12 plus 13. Now this is 31 and this is 25, so this is also 25. Now 4 to 2, how much? 4 to 2 is 8 plus 15. And this is 4 to 3, so 4 to 3 is 9. 9 plus 18. So this is 23 and this is 27. So 23 is smaller, so this is 23. Now I can know the cost of this one. What is this? 1 to 2. 1 to 2 is how much? 10. Plus the cost of this is 25. And this is 1 to 3. 1 to 3 how much? 15 plus this is 25. And 1 to 4, minimum how much? 23. And 1 to 4 is how much? 20. 20 plus 23. Out of this, which is minimum, this is 35, 40, 43. So this is 35. 35 is minimum. That's it. The cost of shortest route.
Any one of you can tell me the path now? Because while explaining, he has explained कि कौन सा particular branch is giving shorter cost than the other.
1, 2, 4, 3, 1.
1, 2, 4, 3.
1, 2, 4, 3.
1, 2 क्यों आ रहा है? Because ये 35 आया because of this part, right? And then यहाँ पे जब हमने discuss किया था, the lesser one was 25 because of this part, and this is directly connected to this.
Is 35. I have shown it using brute force approach and have written the cost here, right? But let us see how dynamic programming works on this one. So from this we can get the idea about the formula, and I will show you how actually we solve it using dynamic programming.
So since the beginning we have been doing this. एक कोई problem होती है, we do not know the problem, we are trying to define the problem, trying to understand the problem, trying to manually solve the problem, and then using the brute force as well as manually solving it using the technique, and then we see the algorithm या steps या recursion जो use हुए. So this is what it's there in the next.
See, the formula is like this. The cost, if it is represented as a starting vertex has 1 and the remaining vertices that I have to visit are 2, 3 and 4, then I have to take minimum, right, from 1 to 2 or 1 to 3 or 1 to 4. So cost of an edge from 1 to any k plus cost of from that k vertex.
Maybe अभी तक MCQ schedule हो गया होगा, but please don't attempt that now. Focus on this. मैं उसका timing आगे का करती हूँ.
See, 1 to 2. So then k, 2 to remaining. If 1 to 3, then 3 to remaining. So 1 to k, k to remaining. Remaining is what? 2, 3, 4 with the vertices. Out of this, whichever one I have taken, I should subtract that one. So k. So this means that I should try for all the k values. So I should take the vertex as 2 also, 3 also, 4 also. So 2 also, 3 also, 4 also. Out of this, whichever is giving minimum that I have taken. So this is c of I comma k, right? C of 1 comma k. And this is cost of remaining. Cost of remaining. And k takes the values that belongs to 2, 3 and 4. This is the formula for 1 as a starting vertex, right? And there are total 4 vertices. Now if I write the general formula for this one, I'll just remove this. If I write the general formula, G cost of I some starting vertex to set of vertices, then minimum of k belongs to this set of vertices. This is C of I to k plus cost of k to set. And from this set, I should subtract this kth vertex. This is the formula. This is the general formula that is followed by dynamic programming. So I have shown you how the formula is derived. Now using this formula, how dynamic programming works, I'll show you, right? See, as we have started solving from here, right? So first value that we'll find out is, let us say we are on vertex 2 and where we have to go next, we are on vertex 2, where we have to go next, nowhere. So nowhere means what? We have to come back to vertex 1. So this is 5, nothing else. So what was this cost? 5. Then similarly, if we are on third vertex and we have to return back to the first vertex. So third vertex return back means 6. So from here also you can take, this is 3 to 1, 3 to 1. So this is 3 to 1, or this is C of whatever I is to 1, right? Then we are on fourth vertex and we have to return back to vertex 1. So 4, 1 is 8. This is remaining vertex is nothing. Now next set we generate that. Now we consider one vertex is remaining. What is that? See, I'm on vertex 2 and the remaining vertex is 3, or I'm on 2, remaining is 4, right? So G of 2, remaining vertex is 3. So what was this? 2 to 3. This was 15. Already we found out this one, right? Formula. If you apply the formula, the same thing happens. Then I'm on vertex 2 and the remaining vertex is 4. So I'm on vertex 2 and the remaining vertex is 4. That is 8. And third vertex, remaining vertex is 2. Third vertex, right? Remaining vertex is 2. Here, 3 to 2. That is 5. Third vertex, remaining vertex is 4. Third vertex, remaining vertex is 4, 8. Third vertex. Fourth vertex, remaining vertex is 2. 4 to 2 is a 5. Fourth vertex, remaining vertex is 3. Fourth vertex and the remaining vertex is 3, that is 6. So we have considered that we are on some vertex and remaining vertex that we have to visit is only 1. Now we have to consider 2 vertices are remaining. So we are moving one level up. So we are on 2, remaining are these 2. We are on 3 and remaining are 2 and 4. So for this we will prepare sets. We are on vertex 2 and the remaining vertices are 3 and 4. And the cost already we have found out minimum of these two by using this formula only we were using. So this is 25. And G of third vertex, remaining vertices are 2 and 4. And we are on third vertex, 2 and 4 remaining we have to visit, and the cost is 25. Now we are on vertex 4, remaining vertices are 2 and 3. So this is 2 and 3, and the cost already we have found out, that was 23. So like a tabular values, I have all the values, right? So already I have shown it using tree, but it is not solved using tree, it is solved like this. Now the last value that is remaining is I am on vertex 1, G1, and the remaining vertices are 2, 3, and 4. This is minimum of what? C of 1 to 2 plus G of 2 to 3, 4, right? I'll use the formula instead of directly getting the answer 35. We know already the answer is 35. Then instead of vertex 2, I will go on vertex 3. Then this will be G of third vertex to remaining vertices that are 2 and 4. Or I'll go on vertex 4, then the remaining vertices are 4 to 2 and 3. Out of this, which is minimum, C 1 to 2, C 1 to 2, 1 to 3, 1 to 4 I need. So this is 10. 10 plus, this was 25. Here, I already have this. Then this is 15 plus 25. Then last one is, this is 20 plus 23. So this is 43, and this is 40, and this is 35. So yes, the answer is 35. Right? So if you prepare these values by using the formula, you can get the answer. This is how traveling salesperson problem is working.
So this is exactly the same thing that is mentioned on the slide. As you can see, we have a function g, जो starting से and remaining vertices तक we have to find the total length of tour. Remaining vertices means capital V के set में से one is reduced. These are the same iterative equations that he has written. The cost from source to remaining vertices is minimum of 1 से k, of a k से remaining vertices की cost, which we are calculating using this formula that was mentioned on the slide. And this is the initialization step wherein because we are moving bottom to up, every vertex is source vertex, that is phi, ki direct cost you get from the graph. So this is the same example that is mentioned here. C25, G25, 3 phi and 4 phi. The next step is we have to consider single vertex in the set. So k value is 1. And that is why we are considering 2, we are considering 3, and we are considering 4. 2 के साथ 3 and 4 की distance, 3 के साथ 2 and 4 की distance जैसे ग्राफ में आ रही थी, 4 के साथ 2 and 3 की distance. Similarly, now we'll consider a set of 2 vertices. So 2 vertices combination could be 3, 4, 2, 4, 2, 3. And then finally, we have all the 3 vertices, 2, 3, and 4. From 1 we have to find, and likewise these values are populated and we are keeping track of parent as well. जैसा जब उसने ग्राफ बनाया, the only mistake was there he should have, when he is pointing out कि ये particular cost minimum है, तो उसी node को, उसी child को if you color from a different color or you circle it double, then we'll get to know कि कौन सा path follow हो रहा है. So this is the same thing mentioned here कि कौन सा path follow हो रहा है is noted by this red cost. ठीक है? So again, practice questions for you people. This is the algorithm. There is one question for you to solve. Maybe I ask this question in the practical. Complexity कितनी हमने बोली थी brute force की? brute force से TSP solve करते हैं तो time taken is n factorial.
n
So
factorial.
we are through dynamic programming trying to reduce this time from n factorial to n times 2 to the power n factorial से exponential reduce कर रहे हैं, which is more exponential or factorial is more factorial. If you people remember, very first module में एक graph था which was comparing all these complexities, so factorial is more than exponential. And this is being iterated n times. So I want a justification for this. Why TSP algorithm say the time taken is coming as n squared 2 to the power. These are the 3 problems that you can practice. So let us take a break over here. We'll complete the last topic and then I'll open up the MCQ. The topic and then you can begin with that. मैं close कर दूं link. Stop doing that. Let me complete the topic. So the last problem that we have in dynamic programming is longest common subsequence. This is a simpler one than the other two that we discussed today. कोई difference बताएगा subsequence और substring में? Online. How do you differentiate a substring and a subsequence? लिखा है तभी मैं पढ़ के नहीं बता रही. So in a substring we have contiguous characters, as in the example, ये जो string दी हुई है, इसमें GAAC will be the substring और CTGT will be the substring, but subsequences characters can have gaps in between, लेकिन sequence में होना चाहिए. So our problem is to find the subsequence from two strings. वैसे बहुत सारे subsequences बन सकते हैं. Like then I have to find the common subsequence. So again, the common subsequence could be many, but our objective is to find the longest common subsequence. So again, maximization objective हो गया. That is why we are taking this problem under dynamic programming, because it is an optimization problem. We need to optimize the length of the subsequence that is common among two strings. Is this much understood? I need a response. Okay. So what are we doing here is again एक recursive equation बनेगी जो उस table को fill करेगी, which will have a value in a cell which will depend on the previous value. Something of similar lines as we have seen the previous two problems. So there is a row comma column value that is a cell. I need to fill the value of this cell. So if I am comparing character by character, दोनों strings के character by character compare कर रहे हैं, अगर character same है, then what I am doing is I am adding 1 to the diagonal element. I comma jth cell के लिए I minus 1 comma jth cell मतलब previous diagonal होगा. उसमें 1 क्यों ऐड कर रहे हैं? Because उस diagonal में the value that is written is अभी तक जितने भी सीक्वेंसेस जितने भी कैरेक्टर्स मैच हुए, अभी ये वाला भी मैच मिला x of I and y of j, that means one more character is matched, so I add a value to it. If there is a mismatch, then what I need to do is मुझे ऐड नहीं करना है, मैं previous row same cell and previous column same cell, previous column same row and previous row same column में whichever value is greater, I'll simply pick that. The maximum of I minus 1, that is the previous column, same row, and I comma j minus 1, same row, previous column. This is same column, previous row, whichever is maximum. So again, because we are comparing character by character of both the strings, एक string की length अगर m है, दूसरे की n है, so the time taken will become m into n because I am having two nested loops iterating over those two strings. An example given over here is ABC dot is one string and ABD dot CB is another string. So these two are compared first. So these two are compared. Though we are comparing each with each, and then C is compared with C. That is why the longest common subsequence in length becomes C. So this is what we did manually. Now let us see how do we do again through the table. इस table को समझने की कोशिश करते हैं with this example, that is एक string ये है, दूसरी string ये है, that is GAATTTCGTTA GGATCGA. So what we are doing is according to the formula. So यहाँ पर again previous row, that is the initial row is kept 0. Why? Anyone? In the matrix, why do I need to initialize the initial row as 0 or the initial column as 0? अभी आज ही देखा हमने वो चीज.
Because we need to consider the previous values.
Right, because LCS I comma j को fill करने के लिए मुझे I minus 1 या j minus 1 या I minus 1 comma j minus 1 लगेगा. That is why I'm initializing the initial row. You are seeing that the string is beginning from second column and from second row. This is initialized as 0. So सबसे पहले हमने क्या चेक किया, G और G मैच आ रहे हैं. So that is why diagonal plus 1. Then again G and A is a mismatch. So what I need to do is previous row का same column, previous column का same row, whichever is maximum. So this value is coming from here. That is why you can see the arrows also drawn. That ये one कहाँ से आया था, ये diagonal से आया था, ये one कहाँ से आया, इस one से आया. And likewise, let us move ahead. G with A is a mismatch, so this one is taken. G with T is a mismatch, this one is taken. G with T is a mismatch, this one is taken. G with T is a mismatch, this one is taken. G with C is a mismatch, this one is taken. And G with G is again is a mismatch, लेकिन अभी दो characters match नहीं हो रहे. यही same G यहाँ पे match कर रहा था, same G यहाँ पे match कर रहा है. इसलिए इस डायगोनल की वैल्यू का 1. Then again mismatch, mismatch and mismatch. Likewise, we have filled this entire table. So final answer मुझे क्या चाहिए था और कहाँ पर है वो final answer? So the last cell will have your final answer, but that final answer is telling you what? The length of the longest common subsequence. मुझे subsequence अभी नहीं मिला है looking at this matrix, right? So again for subsequence, I need to backtrack as we did in the previous example. So how are we backtracking? Again, try to pay attention at this table. ये 6 की value इस cell और इस cell से तो आई नहीं है because वहाँ पे 6 exist नहीं कर रहा. It has come from the diagonal. So A has been chosen. Then again, this 5 has come from here. Because previous column या previous row में वो value existing है. This 5 has also come from here. There is no 5 in the previous column or previous row. So this has come from diagonal. That is why this G has been taken here. ऐसे backtrack करेंगे ऊपर तक. There are two possible paths here. That is both the paths are being shown because there are multiple unique characters नहीं है. You have the alphabets being repeated. So the longest common subsequence is being written this way when I am filling a table from left to right and top to bottom, but backtracking happens from bottom to up. So this is the algorithm for this, wherein while you are implementing, you can use symbols or you can use alphabets to represent the direction. There will be two for loops again because we are trying to fill a matrix from 0 to m and 0 to n. If either of the values, what is happening in this line? If that statement, anyone? So if my initial row, that is 0th row or 0th column, I am initializing the value as 0. और में क्या वो condition भी आ जाएगी जब I and J both are 0? Right? So वो जो एक cell था हमारा, that is the initial cell. This will also be initialized as 0. अब हम क्या करें? Now we are checking if A is a string, B is a string. I am checking for ith index and jth index respectively. If the values are same, then diagonal plus 1. Update, simultaneously update the entry traceback table as well, wherein you are keeping track of the direction. Otherwise, we are checking previous row, previous column ka maximum. So this algorithm is simple and the time taken will be n into n, because we have दो strings दोनों strings का size same होना जरूरी नहीं है. So one string if the length is n, other string length is m. I am iterating within two for loops which are iterating over m plus 1 and n plus 1. So accordingly the complexity is big of n. So these are the applications that you can read through. हमें subsequence find करना है तो कोई भी plagiarism software हुआ या Unix का there is a command as diff which helps you identify दोनों कोड में कितना difference है या DNA sequence को match करना है. So again these kind of algorithms actually work at the back end of these applications. So anyone can attempt this longest common subsequence problem को हम dynamic programming के अंदर क्यों बोल रहे हैं? How is LCS a problem that is solved using dynamic programming approach? Anyone in online mode? We remember dynamic programming का जो basic concepts है. Do we have overlapping sub problems here? We saw subsequences जो बार बार repeat हो रहे थे. Do we need an optimal solution over here? So our objective is to optimize, that is to find the longest common subsequence. So that is why, and the optimal substructure is also required. Every subsequence must also be optimal. ये सारे जो पहले fill हो रहे हैं subsequences, these also must be the longest यहाँ तक के iteration में. Then only it will give you the longest common subsequence at the end when you have traversed the entire string. So these are your practice problems again for this topic. And that covers our portion for ISA as well, that is module 3 and module 4. You need to, again, there are 6 problems that we have discussed. Each student must attempt one problem from multi-stage graph, one from single source shortest path, one from all pair shortest path, 0 in knapsack, traveling salesman, and longest common subsequence. That is minimum mandatory. The deadline again will be Sunday end. Try and complete, because the 3 problems I had given earlier, only 3 problems only you have to do now. So that completes our portion for ISA as well as module 4. Both the MCQs are being opened. Those who had missed MCQ 3, those who had given need not reattempt. I will not take their marks. Jinka miss ho gaya tha, they can attempt. I'll mark 50% of the marks that you score, and module 4 का अभी attempt कर लो. I'll close the link at 2 p.m.
हेलो मिस
Yes.
मिस एक डाउट था मिस एल्गोरिदम जो आपने दिया है तो वो एल्गोरिदम लिखिए कि ऑनलाइन कोई इजी पढ़ रहा है वो लिखे बस जो समझ रहा है
Anything is fine with me. मुझे ऐसा कुछ नहीं है कि जो मैंने कंटेंट दिया वही यूज करना है, but you should be able to justify that.
ओके और सूडो कोड मतलब पूरा सूडो कोड टाइप लिखना है ना
Pseudocode, yes, please make sure if it is asked pseudocode मतलब pseudocode ही लिखना है, किसी भी language specific implementation is not to be written.
तो एल्गोरिदम रहेगा तो स्टेप लिखना रहेगा स्टेप 1
Algorithm रहेगा तो step लिखना होगा. Algorithm is different, pseudocode is different.
ओके
Anyone else, any other doubt with respect to ISA? Because I don't
मिस
think we are
क्वेश्चन बैंक
getting-
मिलेगा क्या?
यही क्वेश्चन बैंक है जो मिला है, सब क्वेश्चन बैंक ही है. क्वेश्चन बैंक से बाहर निकलो. ये सारे क्वेश्चंस एक बार प्रैक्टिस कर लोगे, दैट बिकम्स योर क्वेश्चन बैंक. इफ यू अटेम्प्ट योर एमसीक्यूज सेंसिबली खुद से, यू विल बी एबल टू गेट थ्रू. And let me make this clear again, if you have not gone through the notice, your ISA is in which mode?
Offline.
Offline. Happy about it? नहीं बोल रहा उधर से. Happy about it?